There you go.
Entering now.
So we need to put the slides back, Andrew.
Ah,
Sorry.
boom,
Hi.
done.
Cool. Hi, good morning, everybody. I'm saying good morning because Andrew and I are here joining from the UK, but I'm aware we have an international audience, so it'd be wonderful to hear where you're joining us from, and the time. If you could just let us know in the chat so we know that you can hear us okay. That would be great. Qatar, welcome. Excellent. So we're just going to let the room filter a few people in. We're expecting nearly 100 of you today. We've got people from Malta. Excellent. So this book will be very familiar to you. Some Jamaicans. Excellent. Cool. Hong Kong, 7 p.m. My goodness. J Japan, we've got 8 p.m. as well. Wow. We have a really international Jordan as well. This is amazing. Thank you. I will just, Panama. Okay, somebody else here is in the UK, Indonesia, South Africa. Wonderful. Okay, that means you can all hear me perfectly. Oh, Barbados as well, which is great. So I am just here from Macmillan to thank you all for carving out some of your valuable time to come to this webinar. I trust that many of you have heard of Max Maths and understand and potentially have been to a couple of our other webinars. Today, we have the wonderful Andrew Jeffrey here with us, who is an excellent maths professional, but particularly qualified to talk about this as he wrote the bar modelling books for the Max Maths series. We will be sending you emails after the event, so you can have some slides, the recording, etc. But I personally absolutely love the bar modelling approach. I think it's a really helpful way to think about maths, but the best person to talk about that is Andrew. So without further ado, if you would all join me, if we were all in a room, I'd ask you to clap, but instead you can pop in the chat if you'd like to welcome Andrew. And I will be watching the chat. So any problems, just let us know or any questions, and we will address those towards the end. I've lost the slides here, and
Yeah, I've just,
so
okay,
we'll
hang on a
have those
second.
very shortly, and then I will turn my camera and microphone off, but I will be here to chat to you all and monitor whether you're having any queries that we'd like to get Andrew's thoughts on towards the end of the webinar.
Okay, let's try resharing. Best laid plans and all that.
Yeah,
There we go. Are
excellent.
we good to
All
go?
right. Yeah, we are great. Thank you so
Lovely.
much, everyone. Enjoy. As I said, I'll be in the chat.
Thanks, Katie. Okay, well, welcome and good morning, good afternoon, good evening, or just hello, wherever you are in the world. Um, One of the few positives of the pandemic was that we all got used to doing things together online. So it's good to, I won't say see you, but good to see you. As Katie said, I'm Andrew. I wrote books on bar modeling really for a couple of reasons. Firstly, because I realized the massive potential that it had. Um, and secondly, I really wanted to be able to just say, "Oh yeah, bar modeling. Yeah, I literally wrote the book on that because it's such a cool phrase." I did write some books, and these are my only copies. But luckily for you, Macmillan have got the rights to these, and so you can get them. I'm sure Katie will be able to tell you where, because the Macmillan books, as you know, the Max Maths books are based on the Singapore approach. And I've been out to Singapore a few times, and every time I'm really struck by how they say that they took this approach and really sort of grew it, and it's a core part of their problem solving. So I'm going to hopefully speak for about 45 minutes, run through some examples, some principles, and then leave plenty of time for questions at the end. All right, let's dive in. So the the purpose, I'm going to forgive me those of you who are already experts at this. I'm going to go through the basics as well, just so that we're on the same page. So the reasons for using bar models are basically problems where the answer is not, or the calculation is not clear. So it wouldn't be a do this calculation. You wouldn't need it for that. Um, it's to allow reasoning to take place, which is not the same as fluency, but not entirely different either. It's to I've put there supported by concrete resources, by which I mean when we introduce the idea of bar modeling, we should do it in a practical way first with equipment for younger children, but I'll talk more about that as we go through. Um, and yeah, a bar is simply a rectangle. I mean, there's nothing fancy about it. It's just a representation of a quantity. And the other thing, last thing I wanted to say there is that we use them for, they're very good for solving algebra problems, particularly with older students, but mainly number problems and fraction problems for primary age group. So that's what they are. There are a few different types, but not as many as people who put on very expensive courses would want you to think. There really are only two different types. So let's discuss. So discrete meaning individual sections, or continuous meaning a strip. That's it. All right. And then the way they're used is that you'll be familiar with the phrase the part whole model. So when you're thinking about one thing that is split, that's the part whole, or comparison, where you might be thinking about two different things that aren't necessarily connected, and that's where you'd see a bar model with two or more bars. I mean, you can have two, three, four bars. There's no rule on that. Very straightforward. To try and make that very simple, here's a very simple diagram that I put at the beginning of my books just to explain. Let's take those four sections. So a part whole model, you can see there's a bar and it's been cut into discrete sections, five discrete sections to be exact, and three red ones represent one part and the two yellow ones represent another part. Um, that's different to the one to the right of it, where I've still got discrete sections, 5 and 2, and that might be, for example, ratio question. We'll come on to a ratio question with those numbers quite early on in our webinar this morning. And that's comparing, and that's where you'll see more than one bar. The one below it as well, you'll see more than one bar. You'll see three bars. And again, there are varying lengths, but they're not cut into individual sections. An example of a question like that would be where you might be comparing three different amounts of money or three distances that aren't all exact multiples of something nice and small and convenient. And then the bottom left one, continuous bars. Again, that's just a part whole cut into three parts. That's all, just one. But the difference between the part wholes and the comparison is that the part wholes are thinking about one quantity cut into a certain number of pieces. That's pretty much it. So very, very simple pictures. And they should be simple as well. I think the point of this, the purpose of this, is to help a child find the calculation, to find the maths. And so if it's overly complex and you have to do this and you have to do that, it becomes counterproductive. So I think keeping it simple is one of the secrets. All right. Now, an example of the power of a bar model. This is a test from a national curriculum in the UK test paper for 11-year-olds. But have a quick read through it for yourself. And I don't necessarily need you to answer the question, or I'm pretty sure you could. But my question is, what percentage of pupils got it right? And I'd like you to put your guess. It'll be a guess. I'd like you to put your guess in the chat. So this is pupils in England and Wales, uh, 11 years old, answering that question. What percentage of pupils got that right? I'm going to see if I can see how to find out in the chat. Let's have a look. Chat
In
here.
case you can't see the chat, Andrew, we've got our first guess, which is 45.
I can. I've just seen. Okay, 45. Thank
Excellent.
you, Fatima. I can see that. Yeah. Guys, be brave. What percentage of children do you think? Emily Donkin slightly less optimistic at only 35. So only about 1 in 3 children at 11 got that right. Any more guesses? Okay, just have a you it doesn't matter what you think. It doesn't matter what you think. I'm just interested to see mm, what people would imagine. We're getting steadily more depressive. James James says only a quarter of children got it right. There's a 50. Yeah, okay. Okay. So no one's going for more than half. I guess partly because you're thinking if it was all of them, I wouldn't have asked. And yeah, that's fair enough. And who else is feeling brave? Who else is feeling brave getting that chat? Okay, 5 seconds more. Any guesses? Okay. All right, here we go. So let's see who was closest. Sadly, but well done. It was James. I hope you're shocked by this, but maybe you're not shocked by this. Fewer than 4% of all children got that right. I mean, isn't that horrific? Why? Um, because after all, if you think about the question, what would you like to know about a minibus? Okay, let's see about that question. My watch is talking to me. In the class, 18 children are girls. A quarter of the class are boys. So 18 must be three quarters. Um, so if 18 is three quarters, you can divide that. So six must be. So really, the math you have to do is 18 divided by 3 equals 6, and 6 times 4 equals 24. That's what you have to do. So you'd have thought that a hugely higher percentage of the children would have got that right. But actually, no, they didn't. And it's not because they can't do 18 divided by 3 or 6 times 4, because I'm guessing 95% of them can, maybe higher. It's because they didn't know that's what they had to do. And so I always start with this example as a here's why you need bar modeling. All right, so let's have a look at how a bar model might look. So first of all, a big clue, whenever you see fractions, then you can draw a discrete bar. So there's my discrete bar with 4 equal sections, and I've labeled B in the boy quarter. All right. And all I've done is take that second sentence, a quarter of the children in the class are boys, and labeled it with a B. It follows, therefore, that everyone else is girls. So these 3 sections here, these 3 quarters, must be the 18 girls. Okay, so I do 18 divided by 3. Now I can see that those 3 things have to be 18. Each one must be 6, and that must be 6 as well. And so I can either do 18 plus 6, or I can do 6 times 4 and get my 24. So again, I sometimes say to kids, everything's easy when you can do it, and everything's difficult until you can do it. And they look at me a bit funny, and I say, well, do you remember the day you learned to ride a bike? Now, I don't know if any of you guys can remember the day you learned to ride a bike. I think I can. I think I finally learned to ride a bike when I was a child, one summer holiday. And that day, I realized it was easy, and I was correct. But the day before, I knew it was hard, and I was also correct. And I think those two things are quite valid. Just, so if you can't do it, you can't do it. So the bar model makes this problem simpler because it shows you what to do. Not it won't do the calculations, but it shows you. And I think so for me, that one question above all others is quite an old question now, but it shows the power of a bar model. All right. Um, now let's move on to a different example. Again, this is a sort of ratio example. I'm Funny enough, I'm working in a school 1 day a week at the moment, and they're just about to come up onto ratios, and it's one of those tricky topics because it can be difficult, but because it's a brand new concept, the two dot notation hasn't been met anywhere else up in maths up until that point. It can be tricky, and the teacher was saying, "Well, I'm not sure, how much time we want to spend on it." And I said, "Well, we'll get the counters out." And so I would introduce this by using concrete equipment. Now, the most common one for this is counters, the two-color counters. I'm personally quite amused when they're called double-sided counters because I can't imagine any other kind of counters really. A single-sided counter would be on, but I know what they mean. They mean two colors. So those counters that you've probably got thousands of in your school. You can use cubes as well. But if I want to just model that first sentence, I would get counters out. And I would say, all right, if they share hats in the ratio 5 to 2, that means that if that circle stands for an amount, if Boris has 5 of those, Angela has 2 of them. And I think that's a really simple way of modeling a ratio question. Now, this is practical. If I was to draw this, I would draw it using the bars. But I think to introduce it as an idea, this is quite an interesting one. And you see, actually, there's a similarity now. I wonder if anyone spotted a similarity between this and the first question we looked at. Because there's this idea of the difference. Angela has, I'm going to risk this. Just when we were practicing, I realized I could actually draw. I'm already regretting doing this. Hang on a second. Yeah, okay. There we go. I can actually draw like this on my slide. Oh my goodness, how high tech is that? But maybe I'm okay. 18 fewer hats. Okay, I'm going to get rid of that now. Okay, 18 fewer hats. So that effectively, I can compare the two. Oh, come out of there. Okay, I can compare the two. So I can compare Angela's and Boris's. These two match these two. So this is the difference, and those three must represent 18. And funnily enough, even though this is a different question, we've got the same sort of mathematical reasoning. If 18 divided by 3 is 6, so each circle or each counter that I've got is worth 6. Okay. And then, of course, that means every counter is worth 6. How many hats does Boris have? 5 lots of 6. So it's a very similar kind of question, but a way of how I might be teaching this topic, because, of course, in a test, you're not allowed counters. You just got to, use your drawings. Okay. So simple enough. Um, Other concrete equipment, I like the counters. I like the linking cubes. Now, there are two types of linking cubes that you've probably got. There are some that are, I think this is a generic brand naming, so they might not be called this in your country, but Unifix are cubes which only are fixed in the top and the bottom. So you can just make a strip of them. Multi-link, as you would guess, have got uh, connectors on all 6 faces, so you can make all sorts of 3D shapes. All right. I thoroughly recommend Unifix because for bar modeling, you only ever need a single line. Okay. And the other thing, which I haven't actually written on the slide, is young children cannot make a gun out of Unifix cubes. It's only the multi-link ones. And when you give them that, they'll make it. So that's just an interesting aside. The simple ones that would just have one single connector. It's not a deal breaker. I just think it's a good tip. It's one of those like little teaching 1% difference things. Now, you might be thinking, problem solving, word problems. There's a very good method called the rucksack method. I don't know if anyone's heard of the rucksack method. It was big in the UK about 10 to 20 years ago. Excuse me. And it was a sort of an attempt to address the I don't know what to do when I'm problem solving. When I see a word problem, it was an attempt to do that, and it stands for. Oh, I'm going to play a little game called Rucksack Fortunes. Forgive my slightly strange, quirky sense of humor. There was a game popular years ago called Family Fortunes, where you had to come up with something that was good and you got a ping, and something that wasn't good and you got an But let's see how we go. So Rucksack stands for read the question, underline the key information, choose a calculation, solve the problem, answer the problem, and check your answer. Which on the face of it sounds very good, but actually, let's have a look. Read the question. Is that good advice? That's good advice. Fair enough. Underline the key information. Now, this is where I start to have an issue with this approach, because how do you know, as a reader, what the key information is? You don't. And it's very easy to grasp at words that you see or numbers. But, at 12 o'clock, 7 people got on the number 27 bus. Actually, if it's a question about number of people, 2 of those numbers are utterly irrelevant. Yeah. And what if Mrs. Moore got on the Times, started reading the Times and check her shares and have a takeaway? All those things mean different things. So language, and especially for people for whom English might be the language of the question, but not their first language. And I imagine many, many of you teach in a language to children where the language they're learning in isn't their first language. Then underlining key information isn't a helpful thing to say because it doesn't help them understand what the key information is. So that gets a no. All right. Now, choose a calculation. Again, how? I mean, heads and tails. How do I choose? Just telling me to choose a calculation is a bit like telling me to run faster, and I'd win the race. It doesn't tell me how to do that. So that's Not great. Solve the problem. That's a good idea. Very good idea. You can't argue with solve the problem. And answer the question. Also a good idea. But then finally, check your answer. I'm not sure, sorry. In all my years of teaching, if I see someone who's got a mistake and I say, check your work, it's very hard for them to find it. It's very hard for them to find their mistake, especially if they haven't got anything to look at, any imagery or something. Um, an aside on that, by the way, you probably teach children who are very good at maths and very proud of the fact that they can do it in their head, which is bizarre because where else would they do it? I mean, that is they're not going to do it in their elbow. So they do what they mean is, look, I'm clever. I didn't have to write anything down. Now, this is a really dangerous thing, and I think it's our fault as educators that we often praise children who don't write anything down. They can just um, as somehow clever, but they get the message that if you write something down, it's not smart. And this is where often you'll find with stronger students or older students, you get a reluctance to use bar models. And it took me a while to work out why. And the why is simply, I don't need to do this. I'm clever, and so on. We'll come back to the solutions for that. I promised I would do that later in this webinar, and we will. So, yeah, the thing about check is the more drawing you've done or explanation or writing you've done, the easier it is to check. But most children will not spot their own mistakes, otherwise they wouldn't have made them in the first place. So I'm afraid check also gets a sorry about that. All right. So it's easy to criticize, of course, and this was a good attempt. But so what would I recommend instead? And I was sitting in a cafe one day and I saw one of these. I don't know if you've seen these, the little things that they have on cafe tables, special offers, little triangular prism shape. Um, and I came up with an idea of what if I could put a list of steps, like for bar modeling, and I could put it on all three sides so children sitting around the table could see. And so this was born. And so these are the 10 steps I came up with. And here's the little card that I made up. I don't know if I've got some here, actually. I might have some I can show you later. So yeah, read the question is good advice. Now, this is a top tip, and I'm indebted to my friend, the late Richard Dunn, for this tip. Any word problem will be about one thing. However embellished or flowery it is, it'll be about one thing. It'll be about meters or miles or candles or people or minutes. And so anything else is extraneous. It's like the net curtains of obscurity that just create noise around it. So find the one thing it's about. That's really good. Then this is a good tip. Write the answer, leaving a gap, particularly for a complex problem. Now, the tests that we have in this country, and I think many countries, they solve that problem for you. They do write the answer, leaving a gap. They will put Jane takes blank sweets or whatever. Okay. Now, which model is most appropriate? That's those kind of discrete, continuous, part whole, etc. Okay. Then when you've thought about that, draw your bars and you draw them using the information you're given. Label each, that's an underrated thing, labeling each section. And this is a top tip that I learned from the Singapore approach. Put a question mark where the answer is to be found. So it helps you, that tip, putting a question mark, and also point number 3, helps you focus so you don't get bogged down in all the daily, not the daily, the kind of the extraneous stuff of oh, I've forgotten what I'm supposed to be working out. Um, it's frustrating, those of you who've seen the frustration of a question like, so and so buys a shirt, it's normally £40, in a sale it's 10% off, what does he pay? Yeah. And the number of people that find 10% and put that as their answer, and you're going, oh, I can't give you the mark, that's so annoying, instead of taking 10% off. And so these steps help avoid that. All right, put a question mark where the answer is to be found and write the answer, leaving a gap. And then using your bars, find the calculation needed. That depends on what you're looking for and what you know. Calculate the answer and put the answer in the gap. Now you might say, but Andrew, the original version of Rucksack was 6 steps and this is 10. How is that easier? I think it's easier because every step is easier. It's not, it's 10 steps, sure, but it's not that any step is particularly difficult. putting a question mark, not a big thing. All right. So I can kind of go through those 10 steps with you as we solve some problems during this session. All right. So before we go on, the two key relationships that are most important in understanding successful bar modeling, the relationships are the first one, part pole, which is well known, and this is a well-known model of a whole split into two or more parts. And there's two games we can play with this. The first game is called addition, and the game of addition is if I tell you the parts, can you tell me the whole? All right. And obviously children can, but there's also a game, whoops, of subtraction. That 17's got a little bit excited and gone too far. The game of subtraction is if I was to say 17 is the whole and 3 is one of the parts, can you tell me the other part? Now that becomes a game called subtraction. All right. And that will become important. And the other one that I don't think is talked about enough really is this. It's sometimes referred to as multiplicative reasoning. If I know the two factors of 42 in this example, this pair is 6 and 7, excuse me, then I also know that 42 divided by 6 is 7, 42 divided by 7 is 6. I should know that 1/7 of 6 is 42, 1/6 of 7 is 42, 6 lots of 7 would be 42, 7 lots of 6s would be 42, and so on, and so on, and so on. So, sometimes I think when we teach children their multiplication tables, which we should, and they're very important, we perhaps also need to focus on what else they know. Because if I have something 42 pounds and I want to share it into 6 parts, I need to know that each part is 7. I need to understand why. So with that said, here's a game you can do to warm children up into this idea of the bar modeling. Oh, actually, I'll tell you something I should have said. Why am I talking about this? This isn't bar modeling, but these are prerequisite things to understand. If children don't have a good grasp of those relationships, they will not understand bar modeling. That's why it's so important. And forgive me for not saying that earlier. So again, you will be a successful person at bar modeling if you, to the extent that you understand the concepts of these number relationships. All right. So it is worth not jumping straight into the bar until these relationships are secure. All right. So here's an example. Let's say I have 2 counters on that mat and 3 on this one. These are kind of representative. I've got A3 laminated color boards of this. Just very, very handy things. What do I know? Well, I know some things that I can say abstractly by moving those around. I know quite a lot of things. I know all, what is it, 8 things there? Yeah. And there's other things that I can go on to say as well. Okay. And this is the concept of difference. Remember the idea of the difference in the hat question. Okay. So I'm sowing the seeds. This is all about pre-teaching. The first step of mastery, we talk a lot about mastery, don't we, these days? But the first step of mastery is actually pre-teaching. And so to pre-teach for younger children. Now, for those of you who are not UK based, which is most of you, where it says FSKS1, what I'm referring to is children between the ages of sort of 3 and 6, 7. Okay, 3 and 7. Like that. And there are 4 specific tasks that I think will benefit children who are beginning to learn, and it is part of their bar modeling journey. So the 4 are this. How many? It's very, very simple. You'll have a dice. I'll have a dice. I'll roll it and get a 2, and I'll get 2 cubes, and you'll have 4. And you can just say, okay, how many? I've got 2, 4, and we've made 6 altogether. All right. Then, very similarly, we do the same thing, but this time on a mat. All right. And we can start saying, my part is 2, your part is 4, the whole is 6. Yeah. You notice that we could move on to 3 parts. No problem with that at all. Okay, you could just put them in groups of 3. Okay. These are very simple games. Roll a dice, have some cubes or counters. More or less is the next one. Simple. Okay, I thought I'd try and be really clever and have Ben and Ali and Raj that would spell the word bar, but I got them the wrong way around, and now it spells bra instead. And I just amused myself, so I didn't bother to correct my error. So apologies for that. But now we all roll a dice, all 3 of us, and Ben says, I have 2 more than Raj. And Raj says, I have 2 fewer than Ben. And Ali says, I have 3 more than Raj. and I have one more than Ben and so on. So it's all about, can you say how much more or less you have than somebody else? So we're beginning to get this language of comparison in. Very simple. These are very simple games. Barely bar modeling, but hope you can see how the first one leads to the second, which sort of leads to the third, which finally leads to the fourth, where now they play it again, but this time with quantities that they can then make their own part whole model. So you see the scaffolding process from a pre-drawn mat or from cubes, and then they start to sketch things out a bit. Okay, so very simple, nothing very exciting there, and that will start to help them with their simple bar model problems. But before I show you the key stage 2, by which I'm saying children from 7 to 11, I think there's a few things that they need to know before they move on. One, I can't speak for everyone's jurisdiction, but one of the issues that we're finding in the UK is that our curriculum moves on at such a pace that children don't spend enough time really deeply understanding. And that's another thing that the Singaporeans do so well. They don't get bogged down in things too early, too soon. They just get those key number relationships right. So they'll spend ages looking at how to make five, for example. So are these truly understood? All right. The second thing is the inverse, the idea. So comparisons, right? If I've got three fewer things than you have three more things than me, and the difference is three. And then the multiplicative relationship as well. Look, if I have twice as much as you have half as much as me. And then the multiply and divide. In fact, only yesterday, a child said to me, Mr. Jeffrey, how old are you? And I laughed because I always give the same answer. I said, I am exactly twice as old as someone who's half my age. And they go, oh, and they go off to think about it. And I'm sure at some point they suddenly realize that's not much of a clue. But hopefully I've taught them something about inverse. So if someone asks you how old you are, that's your answer next time. Okay. And finally, this is a huge one. Okay, fraction complements. If a quarter of something's red, then not red is three quarters. And again, this is best done with cubes. Okay, this is best on the cube. So I can say, oh, I have a quarter and you have three quarters. We'll show you an example of that coming up. But I think knowing those things is going to help them with their bar modeling. So here's the kind of things I would do for older children. All right, I have 2 out of 6 and you have 4 out of 6. So the same thing, we're just rolling the dice and making some cubes. Okay, then we literally have them there. I have 2/5 is red and 3/5 is yellow, just about that. Okay, and now more or less exactly the same, but this time the difference, I would bring that language in more thoroughly. And then the thing, I guess, the one I'm probably most pleased with, coming up with this idea of bar modeling backwards. And bar modeling backwards simply means, what can you tell from this? All right, let me say a bit more about this. And this is the first of our moments to say, hey everyone, if you've got children who don't want to do it, this is what to tell them. So first of all, I would draw 3 boxes of one color and 5 of another. You don't need to color them particularly. I'm not a great artist, but I noticed at one point that by just adding one line, these cubes can become boxes, and that line is that one. If you just draw a line like that, your eye almost makes those cubes into hollow boxes. It's like, I'm so excited by little things like that because I'm not very good at drawing. Now I can say loads of things like, if I put 100 grains of rice equal in each section, how many are in the yellow line? Okay, how do you know? But I'd be much more subtle. I go, how would you find out how many was in each blue box if I put 100 grains of rice in the blue line? How would you know? And I don't accept the answer of 20. I only accept the answer of, I would divide 100 by 5. So you can start to draw these without a word problem, and that's a bar modeling backwards. You have a bar and you say, what can you find from this? Okay, so I could, for example, say, if there are 8 there are the same number of grains of rice in each box. If there are 8 more in the blue line than the yellow line, how many are there in the yellow line? And that's actually quite hard until you look at this difference idea. Oh, I see, there's 4 in each of the sections because 8 divided by 2, so 4, 8, 12 in the yellow. So this, if you look at the book, there's a lot of ideas about this backwards idea. Now, final misconception, then we'll do some bar models to finish. Bar models will make my calculations easier to do. I remember at the age of 40 getting a pair of running shoes. I was having a midlife crisis. I thought, oh, maybe some running shoes will help me run better. And I put them on and like nothing happened. Well, of course, they don't make me run, but they help me run. And bar models don't make your calculations any easier. Absolutely not. What they do is they help you find them. That's the crucial thing. And I think if we start from that point, we're going to be in a really strong place. So bar model won't help me do the calculation. It'll help me spot the calculation. All right. That's kind of it, really. Finally, this is for you. I wouldn't show children this particularly, but when after the webinar, study this because it will help you help children decide what kind of bars to draw. I'm afraid there's no shortcut. All right. I designed this as a how do I know which bar to draw? There is no shortcut, all right? But I have, by asking a couple of questions, 2 questions, then you can choose. So I think I've narrowed this down to the most simple way of doing it. But let's move on. Right, some bar modeling questions to just show you, having got those things out of the way, having to show you. This is for younger children. My uncle has 4 hats, but my aunt has 3 more than him. How many does my aunt have? Okay, so how might a child go about this? Well, I'd have a look at it. Let's have a look at my 10 steps. Read the question, done that. Find the single thing it's about. It's about hats. It's not about my uncle. It's not about my aunt. Write the answer, leaving a gap. The answer would be my aunt has. Okay, which model is most appropriate? Well, this is a comparison model. All right, yeah. Draw the bars. All right, let's draw the bars. There we go. And I'm going to use my little mini whiteboard. I'm going to put cubes on. There's I've tried to write uncle and aunt. Okay. And my aunt has 3 more. Label each section. I've done that, uncle and aunt. Put a question mark where the answer's to be. Well, how many does my aunt have? So I put my question mark there. Use my bars to find the calculation needed. Well, I think I just count them. Okay. And the answer is 7. Okay, so that's just how I might introduce a very simple one to, you know, a 6, 7-year-old child. Rajesh runs for 20 meters. Kathy runs for 34 meters. How many more meters does Kathy run than Rajesh? Okay, we've read the question. What's it about? Meters. It's not about Kathy. It's not about running. It's about meters. The one thing it's about is meters. So I would write Kathy has run blank meters. Okay, more. Then what model? Well, this is a comparison model. So I'm going to have 2 bars, okay, and they're different amounts. So let's have a look. I'm going to draw a bar, and I've tried to make this quite realistic. This is how I think children would draw those bars. And the how much more bit is that difference there. Now I can find the calculation. What do I need to add to 20 to make 34? So there you go. There's my calculation. 34 minus 20 equals. Those dotted red lines are quite useful. Initially, we use the counters, but I want to show you that there's other ways to do it. Because obviously, without counters, we want to move to an abstract way, and that's how we do it. Okay. Everyday Tika picks 5 flowers from his garden. How many flowers has Tika picked after a week? Okay, we've read the question. We have you can, by the way, I should have said, I'm sorry, for all of these, if you've got a pencil, just do your sketches. You won't be embarrassed or anything because no one's ever going to see what you do. Just how would you think this would be a good way for children to do this? All right. How many flowers has he picked after a week? Well, this I think is, yeah, discrete sections of 5. Yeah, just one person, 1 bar. And you might have come up with something like, I think these I'm going through quite quickly, these examples, because they're quite simple. But the thing I want you to emphasize to you is that question mark. That question mark is immensely powerful. Like, what is the question asking me? And there I've just done 7 lots of 5. Okay. What is the question really asking? That I think is a massively powerful thing. That and what's the single thing? I think those would be my massive wins from that. Okay. Okay, what might a child do? Give you a second to look at that one. Think about your 10 steps. And you might have come up with something like this. This is what a child actually did for me. So I took a photograph of that one. Looks a bit like teeth, I think, but there you go. 16. And I like the way they've done 16 divided by 4. That's quite unusual. I think it was a 7-year-old did that. That's quite unusual. 16 divided by 4 is 4. Okay. 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 12 children at a party, a quarter go home. How would you draw that? I think before bar modeling, I would have been tempted to look. I'm going to risk this pen thing again. I would have been tempted to, let's do this, to do, okay, so 12 minus, okay, so 1/4 gone. Oh dear, not very good at writing. 1/4 gone, 3/4 left. It just would have looked like a lot of numbers and a lot of stuff. And I think that's okay for children who get it. But for those who don't get it, I'll rub this out. Rub this out. For children who don't get it, um, it's not. And I think this is why it's so important. So a quarter's at the party, how many? Well, this is fractions. And when you've got fractions, it's always, oh dear God. When you've got fractions, it's always a discrete amount. So here is, I think, a realistic version of what a child would do. I've drawn quarter. I've said that's worth 12. Crossed out a quarter. So I've got this much left. Okay. How many? So 12. Well, I know how to find a quarter of 12. I divide. So that's 3, 6, 9, 12. How many left? 3, 6, 9. Okay. All right. Now, a few for those kind of more advanced or older children again. And again, you'll see, sorry, let me just go back a few. See, I think one of the things with showing you simple bar models like this is you and your children might be going, yeah, but I could do that a quicker way. I could do it. The thing is, um, it's kind of like a baby learning to walk. They can shuffle along on their bottom faster initially, but persisting with the whole walking thing pays dividends. And I think some of these examples I've shown you, I'm about to show you will make that point. So Will, Dan, and Ben, they go cycling. They all choose different routes. Will cycles for 18 miles. Dan cycles for 14 miles and Ben cycles for 8 miles. How far do they cycle all together? This is quite a simple example. So what's the one thing it's about? Miles. Are we going to do discrete or continuous? And I think we can say we're going to do continuous. Now here, you could have put them, there's two ways you could do this. You could either put them as separately, but then the question mark has to cover all of them, or you could put them in one horizontal strip, which I quite like as an altogether. And then the question mark goes all the way along the top. But basically the calculation then becomes 18 plus 14 plus 8. So there's two ways of looking at that. Can you see? And people say, well, which is correct? And that's a nonsense question. It's a nonsense question because what is correct is the model that leads you to the right calculation. So if your model looks like a bit of Picasso or it looks like a spider has crawled through a bottle of ink, it doesn't matter. As long as your bar model leads you to add 18, 14, and 8, then your bar model is correct. It's a correct for you concept. I personally prefer for that question the top one, I think, but quite happy to go with the second one as well, particularly as they add in columns anyway. All right, so slightly harder. Have a look at this one and try drawing this one yourselves. So I think this one is harder, isn't it? Although it's a very similar one, I think it's harder. So what's it about? It's about meters. It's not about swimming or Jenny or morning. Okay. And again, I think this one shows why on the previous slide I showed you, I think it shows why the top bar might be more useful. So I wonder what you've drawn. Hopefully you've had a go at it. Um, something like this, maybe. My whole thing is a kilometer. My morning section is 200 meters. My afternoon section is 350. I think I know how I can find the rest. I think if I add 200 to 350 and I subtract that from 1,000, I think that's what my picture is showing me. Okay. Now, this one, I think we might make this the last one. Okay. This is the one that I wrote for two reasons. Firstly, I wanted to show the power of bar modeling to solve really hard questions. And secondly, I wanted an answer for children of 11, 12, 10, 11, 12 who go, I don't need this. This is boring. I can do this much faster myself. So I came up with a question based on Little Mix and who I was listening to at the time. And I said, right, answer that then. And this is an almost impossible question to answer, I think, without some kind of drawing of a bar model. So I don't know if you want to have a go at that. Um, I know that would be cruel of me, but let me show you why this is such a useful question. If you have students who are reluctant, this this is my go-to question. Perry, Jessie, Jade, and Leanne write songs. Perry and Jessie write the same number of songs each. Jade writes twice as many as Jessie, and Leanne writes twice as many as Jade. Leanne writes 24 more songs than Perry. How many songs do they write altogether? Now, as a mathematician, I'd probably crack into some nice, tasty algebra for that. But actually, the bar model is the same logic. Let's have a look at it. So here are my four, and you might have ended up with something like this. So here I'm going for discrete because the idea of twice as many means that there's twice as many blocks. So Perry and Jessie, I'll just give them a block worth a certain amount. Jade gets twice as much as that. Leanne gets twice as much as that. And then that key information, Leanne writes 24 more songs than Perry. So comparing those bars, I see a difference of three. And therefore I've solved that each individual block, if you like, must be 24 divided by 3. So that's 8. But and so okay, well, there's 8 in every one. So there are 8 little blocks, 64. The answer is not the important thing. The big takeaway from this question here is simply this. What chance have you got of solving a problem that's that complex without drawing a bar? And also, what do you say to children who think they don't need to do it and therefore not interested in learning the method? So from that point of view, I think this is a useful question. All right, we're nearly at time actually. So I'll just show you a few more examples of the power of the bar model. This is a very common kind of question. Almost every year in the UK, there'll be a reasoning question like this, and it's easy to get it wrong. But again, I think if you draw a bar, there we go, there's my total. I think the question becomes two lots of £1.30 taken away from £5 is pretty straightforward. Now, actually looking at this one, it does occur to me that a lot of children, their language skills are not good enough to get to grips with this without drawing a picture. So drawing, like you could even draw carrots, so bananas, this one, you could even draw things out. It really doesn't matter. There's a funny saying, if it's tricky, draw a picky. Right? And so it's just about increasing children's chances of getting it right. That's all. That's, I'm going to skip that one for time purposes, but that's quite hard. Yeah, again, they get more and more as I was getting to really more complex ones, they get more and more complex. But I think what I'll do is I'll skip through these and allow some time for anybody with a question. So over to you, and thank you for listening.
Thank you, Andrew. I think I just thought I'd come on while we're waiting for them in the chat. I did post a message to say that I will be checking there if people have
Sure.
questions or comments.
While you're waiting to collect them, I can go through one or two just for people to to look at if you like. So this, for example, this is a really tricky one. Dave and Lyd are keen readers. They have the same number of books, but Dave gives Lyd a fifth of his books. Now she has 20 more. How many did I mean, that's a very difficult question. I would struggle to answer that without a bar, and I think that's another one. Okay. Okay. So that's how might I do that? Well, this is one of those ones where the bars change during the question. We haven't got time in a webinar like this to go through what happens when bars change, but a couple of examples to get get you thinking. We start with them having the same amount. And I've kind of thinking, well, if I'm going to give away a fifth, then I'm thinking Dave's got 5 bits and Lid's got 5 bits. Okay. And now maybe if he gives her 1 bit, he's got 4 and she's got 6. And now I can compare that she's got 2 extra bars. So those 2 extra bars are the 20 extra books. Okay, so each bar must be worth half of that. Okay, so 10 and so on. So yeah, that's a quite a complicated idea. Um, there, I just saw a question about that. Yeah, this afternoon or whatever time it might be, I'm planning to do the same topics unless anyone is going, could you talk more about X, Y, and Z? In which case I will do that. Okay, while we're waiting for that, Eric and Ernie tell jokes. See if you can. How might a child have a go at that one? 4 times as many. So there's that ratio there, that discrete bars, individual pieces. Ernie tells 4 times as many jokes as Eric. So straight away, 4 times as many. Nice and easy to draw. Okay, and altogether they're 100. So that little double-headed arrow, 4 times as many, 100. So 100 must represent the 5 blocks. So do 100 divided by 5. Each block is 20. And so how many jokes did Ernie tell? 20 times 4 is 80. Okay. So I'm just having a look. I can see the chat actually now. I can see the chat box. Oh yeah, good. SEND. Yeah, I think particularly SEND. Because often bar modeling, that the calculation isn't that hard. It's finding it, and that's the absolutely crucial point. Okay, good.
So we have a question about specific resources. I know we don't necessarily publish them at Macmillan, but you may well know of some, Andrew, that would support SEND students in addition to obviously using the bar modelling approach.
Resources in terms of practical physical resources or online resources.
I would say probably both the
Okay.
question encompasses, but
Hmm.
Fatima will likely correct me in the chat if I'm wrong.
Okay. Yeah, so physical resources, practical resources, the things that we've I see if I've got some to hand. The thing that we've mentioned. So laminated mats with part hole models, or for 10 frames or bar models, Unifix individual cubes, 2 color counters, whiteboards. Those are the crucial, I think, the main practical physical resources we need. Online resources. There is a website that allows, now I'm just gonna, while I talk, I'm gonna try and dig this out, because there is um a website and I can't remember what it's called at the moment. It could be, yes, it is. Okay, so if you go to, I'll put this link in the chat. Um this this is a, oh, hang on a second. What's happened there? Copy. Wait a minute. Copy. Right, I'm putting a link in the chat to a website, someone I know who creates a website. This is a free website to use, so it's not a commercial competitor or anything. Oh, Lexi's beat me to it. There you go. And you can put bar models. You can build your own bar models there. But honestly, I think low tech is almost always best. So just any whiteboard that you can draw rectangles. I just sketch. I think it's important. Oh, my message didn't show to everyone. Ah, thank you. There we go. So yeah. So now I think you can all see the message that Lexi's put in. I put it in, but it didn't go to everybody. So Lexi's our technical genius, who's that's why you can see that from Lexi. Thanks, mate. That we good. And yeah, that's the website that I would use. But honestly, I would recommend not using websites. Just practical. Keep it very, very simple. Remember what we said at the beginning. It's the idea is to simplify, not complicate. So from that point of view, I think absolutely would stick practical and just get them to draw. And if we can get students out of the mindset of, aren't I clever? I didn't write anything down, because that's ultimately quite destructive. Yeah, good. Oh, I've just seen on the chat also Macmillan has teacher support resources specific to this. Okay, well that's useful, probably worth checking out if you're on the Macmillan portal as well. Okay, I will stop sharing. There we go.
Yeah, we're just getting one of my favorite things about webinars is when you get the community suggestions as well, So I've just seen that we've got a comment about how useful colours and small colourful boxes like the Rubik's
Mm,
Cube, I
nice.
suppose, can
Yeah.
be. And I did also notice there was another website shared, which is called Maths Playground, which I don't know whether you've heard of, but Shirley has shared that with everybody too.
Hmm. Oh, thank you. No, I have heard of it. I've not been on it for a while, so maybe I shall have a check of that as well
Yeah.
later. Good stuff.
Yes, and we're now just getting our thank you messages. So I think I will just thank you from Macmillan, Andrew. It was really amazing. It always is. And also, as I said at the beginning, in case anyone missed it, thank you all for sharing your valuable time with us. We will be following up with the recording if you missed any of it, or if any of your colleagues signed up and then couldn't make it on the day. And we will also share some useful information in the post-webinar email too. So, for example, about those resources that are available online for you to teach these courses. Um, but that's all that's left for me to say. So thank you so much, Andrew, and thank you so much to all our attendees. It's been a
Perfect.
fantastic webinar. I will close it now. So thank you, everyone.
Thanks for your time.
Thank you. Bye.
All good.